Hello and welcome back to Crash Course Trigonometry, where I'm trying to get a basic understanding of trigonometry into your brain so that you can use it and go on into your life. You know, if you need a little review or just learning all of trigonometry before a class. So today we're going to start with basic right triangle trigonometry. There are three basic definitions of trigonometry itself. This is the second one, and it says if triangle ABC is a right triangle with C equaling 90, so angle C down here equaling 90, then the six trigonometric functions of A are defined as follows. So we have sine of angle A, which is right here, is equal to side A over side C. Cosine of angle A would be side B over side C. Tangent of A would be side A over side B. Cosecant of A is side C over side A. Secant of A is side C over side B. And cotangent of side A would be side B over side A. So what does that mean for us? That means that we now have equations. We have ways of figuring out what the angle is or what the side is. And to remember all these six crazy, they're not that crazy, but crazy equations, we can remember the saying SOHCAHTOA. And I know it sounds strange, but it's an acronym and it makes sense. It stands for sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. And what that means is sine, the sine of an angle, is equal to the opposite side over the hypotenuse. So the sine of angle A would be equal to the side opposite of A and the hypotenuse, so A over C, which it is, And cosine is adjacent over hypotenuse, which is ka. So cosine of an angle, so angle A, would be the adjacent side over the hypotenuse, so B over C. And tangent would be opposite over adjacent, which is TOA. So the tangent of A would be opposite A over adjacent B, so A over B, which it is. So if you remember SOHCAHTOA, then you can remember all of these pretty easily. Next, we are going to jump into the Cofunction Theorem. And the Cofunction Theorem states that a trigonometric function of an angle is always equal to the cofunction of the complement of that angle. So let's start with complements of angles. The complement of an angle is when one angle and another angle add up to 90. So the complement of 45 would be also 45, because 45 plus 45 equals 90. And the complement of, 30 would be 60, because 30 plus 60 equals 90. So whatever angle adds to that original angle to make 90 is the complement of that angle. And with the cofunction theorem, we can use these cofunctions that exist right here, sine and cosine, cosecant, secant, tangent, and cotangent, and we can find what their cofunctions of the complements equal. This theorem basically states that sine of 30 is equal to cosine of 60 because sine and cosine are cofunctions and 30 and 60 are complementary, so they are equal, if that makes sense. So there's three groups of cofunctions. There's sine and cosine, there's cosecant and secant, and there's tangent and cotangent. So if you know one of the cofunctions, you can find the other one's complement, if that makes sense. So the sine of 30 would equal the cosine of 60 because they add to 90. The cosecant of 42 would equal the secant of 48. And the tangent of 25 would equal the cotangent of 65. And this works for all angles up to 90. Next, we're going to hop into the world of inverse functions. And I know it looks crazy, but it's really not. It's just another button on your calculator. So here are our six trig functions: sine, cosine, tangent, cosecant, secant, and cotangent, right? And these are their inverses. And I know that negative one looks scary, but it's just the inverse of the sine. So it's like multiplying and dividing are inverses of each other. If you multiply by 3, you can divide by 3. And that's what you do in most equations, like if you're solving for x, you would if it was 3x, you divide by 3 on both sides. This is just a way to do that with trig functions. So over here I have an example. Sine of theta equals 1/2. We are trying to find theta, and we don't know what theta is. That's our variable. And so we have to get rid of this sign so that theta is by itself. And to do that, we take the inverse of it. So we use inverse sine. So we take the inverse sine of theta and the inverse sine of 1/2. So we take the inverse sine of both halves and use the inverse function. And then the sines cancel, and we're left with theta equals the inverse sine of 1/2, which is 30. And, I know I went through that pretty fast, but it's pretty simple. It's just how you undo the trig functions so that you can find the angle or the other variables that you need. Next, I'm going to go through an example of solving a right triangle using all these things we just learned in chapter 2. So we're given two sides of a triangle, A equals 2.73 and B equals 3.41. And we have to find all the remaining sides and angles. So I think we should start off by drawing the triangle. So I drew our basic triangle. It's just a right triangle, ABC, same thing we've been using for this whole lesson. And I put in the sides A equals 2.73 and B equals 3.41. The angle C is always the right angle in a right triangle. It just makes things easier, it's just one solid thing that everyone uses. The right angle is angle C. So where do we go from here? We have to find side C, angle A, and angle B. So I shall write those down. We must find side C, angle A, and angle B. So how do we do that? Well, side C, it's a right triangle, and we can use the Pythagorean theorem. So if we do this, we have side A is 2.73, and we square it, and side B is 3.41, and we square it, equals C squared, because the Pythagorean theorem, A squared plus B squared equals C squared. And then from this point, we can use our calculator, and we can figure out what C is. So I'm going to cut to me solving C, but I'm going to use my calculator and type it in until I just solve for C using normal algebra. Okay, I wrote it all up on the board. We have 2.73 squared, which is 7.45, and we have 3.41 squared, which is 11.62. And if we add those together with the Pythagorean theorem, then we get 19.081 equals C squared. We square root both sides, and we get C equals 4.368. So now we know the length of side C, 4.368. Next, we can move on to the angles. Now, all the angles in a triangle have to add up to 180, but we don't really use that here. We just kind of use sine and cosine to figure out what the angles are. For example, for angle A, we can use any of the three sides and we can figure it out. So, let's use sine, just because it's simple, Sine of A equals, so if we use SOHCAHTOA, opposite over hypotenuse, right? So, sine of A would be the side opposite of A, which is 2.73, over the hypotenuse, which we just figured out to be 4.368. After that, we can take the inverse side of both sides, sine -1, sine -1 of both sides, which cancels out the sine, and we get A equals 38.682. And I just used my calculator for that. There's an inverse sine button, an inverse cosine button, and an inverse tangent button. So you can choose any of your three functions to use to figure out your angles. So now we know angle A is 38.682. And at this point, we only have one angle left to find, and the inside of a triangle always has to add up to 180, right? So if we take 180 and we subtract this 90-degree angle C over here, and we also subtract angle A over here, which is the 38 degrees, 0.682, you can barely see it, then we can get our final answer. Angle B equals 51.3178. And at that point, I think we've solved the triangle. We have found all the missing sides and all the missing angles of the triangle using the Pythagorean theorem, just the rules of triangles, and the trigonometric functions. And it's not that bad, honestly. You got this, man. Woo! But yeah, that, yeah.